Okay, the first topic, which we'll just a very brief introduction to right now, is what I call petroleum nomenclature. And that really consists of three things. You have quantities, like pressure, okay? And you have a symbol for that quantity. And in our industry, the SPE symbol is lowercase small p, not capital P. Okay? And if you think there's any chance in hell that you're going to do your project or thesis with me, I recommend that you differentiate between the small p and the big P, and because I'm a little bit picky. And if you're curious about these symbols, the book that you're using in the course, you just kind of follow the guidelines there. It's pretty much all the symbols are there. So it's lowercase p, and then we have the units of pressure, for example, the units of the quantity. And here we have this problem of multiple sets of units or multiple units for the same quantity. We have what's called the SI system, which is kind of a derivative, if you will, of what used to be called is called the metric system. And we have what the SPE calls the field units, which is basically the imperialistic American units that we in part derived from the British. So we have to blame somebody. Do the Aussies still use...
We're on SI.
So that's what he thinks. Yeah. There's really nobody who uses pure SI. We'll show you that here shortly, but there's a very rigorous and clean kind of set of unit standards called the SI, which is something in French. And then what I'm going to do is try to give you the petroleum industry. If they don't use field units, they use typically a hybrid SI unit. Okay, it's maybe not even accepted in the SI, but so for example, for pressure, we've got what's the unit for pressure in SI? Pascal. Yeah. For our friend Pascal, but then what's used in all these SI countries, for the most Canada and most other places, most of the industry uses what's called a bar. Okay, but a bar is not an acceptable SI unit. Okay, because it's 10 to the fifth, 10 to the 5 pascals. Okay, so that's equal to 10 to the 5 pascals, and there's not a prefix to put in front of it that makes it 10 to the 5th. There's not a 10 to the 5th prefix, I guess. Now there are things like kilopascal, which is 1,000 pascals, and that's used some places. Canada typically uses the megapascal. I think that's the SPE SI unit for pressure, preferred. Megapascal. But bar is what we use most of the time, like in Norway, which is supposed to be SI. They use bar. Okay? And nobody uses Pascal, hardly, because the magnitude is so small. I mean, the pressure in this room is 1.0135 10 to the 5th Pascal. I mean, just give me a break. So, And the unit in field is pounds per square inch. Pounds per square inch. Okay. Any questions about pressure? So what we're going to do is I'm going to go through the most important quantities and give you their symbols, talk a little bit about the units, the bizarreness of the units in petroleum, and they are bizarre, a little bit, and then it will eventually talk about the conversions from bar to PSI or to megapascal and so forth. And eventually you need to learn to do some of these conversions in your head without a calculator. I mean, at least sitting in meetings to get the order of magnitude down. Okay, because if you grew up with SI or understand bar and somebody's talking, Yahoo in Oklahoma is talking about PSI, and you just don't understand any number they're throwing out, then you know it's a problem for you as an engineer, because engineers, the numbers mean everything, right? So you have to be able to make these quick translations in your mind, sitting in meetings. Okay, so what we'll do now, we'll take a short break. So we'll continue on with pressure, Mr. Blaise Pascal. Now, what's special about pressure in the petroleum industry is that we have two kinds of pressure that we operate with. Okay. Before I go there, I don't want to get into the details of this, but this stands for pounds per square inch. And the pound is a term that has two meanings. You have a pound mass, like a gram mass, and then you have what's called a pound force. It's very nasty, confusing, and really I don't want to go there right now. But this, for your sake, pound per square inch, that particular kind of pound we're talking about here is obviously, it's because pressure is force per area. This is a pound force, and the symbol for pound is LB. That's the short for pound. And because there are two types, we typically, you'll see it written like pound lowercase f for force. Okay? So anyway, that's just... but aside from that, we have two types of pressure that we use in the petroleum industry. And one is called the most normal, which is what most people use. We refer to as the absolute pressure. And the other is referred to as gauge pressure. Okay? And so I'll just, I guess I can just write, if we give this the symbol, you know, we don't use the symbol, but let's just say we call that pressure I don't know, absolute, okay, and this is our pressure gauge or something, okay. The pressure absolute is by definition, well, really makes more sense to define the pressure gauge, since it's kind of uncommon. So the gauge pressure is equal to the absolute pressure minus the absolute pressure at here, at the sea level, or on the surface of the earth. Okay?
Standard conditions.
Yeah, and we usually write this as SC for standard conditions. But what is standard in Denver, Colorado is not Stanford and Trondheim, because there's a little bit of difference in pressure because the elevation. Okay? Standard conditions. Around 1 atmosphere, little more than 1 bar, 14.7 psi. But this is a concept of gauge pressure and absolute pressure, and by definition the gauge pressure is equal to the absolute pressure minus the absolute pressure at here. Okay? So like, what is the gauge pressure here in the room? Is 0, pick your unit. PSI, 0 Pascal, 0 bar. Okay? Because we just take the pressure here. Okay. If we go to the fjord and we dive 10 meters down, is any divers in the group? Australians, they all go diving. 10 meters, they go to get their food. 10 meters down below the water, what's the pressure there?
1 bar.
Okay. It's 1 more bar than it is here on the surface. Because in water, you generally gain 1 bar for every 10 meters you go down. Okay? So if you go 100 meters down into the water, then it's 1 bar here plus 10, right? For every 10 meters of water, you approximately add 1 bar. That's a static column of water. We'll learn about that later. So the point is that if you go down, you've got your water here, and we usually put that like that. And then here, this basically the gauge pressure, that will be 0. Okay? So if you go down 10 meters, okay, because the density of water is 1,000 kilograms per cubic meter, and you multiply it by acceleration due to gravity, 9.8 meters per second square, and you get something around close to 10 to the 5th pascals. Okay. So down here, the gauge pressure at 10 meters would be about 2 minus 1, which is the surface condition pressure, times 10 to the 5th Pascal. Right? Something like that. So that would be about 1 10 to the 5th Pascal. About 1 bar. But that's our gauge pressure. And so when we write bar, or you could say, if we use my units in Oklahoma, down here it would be about approximately 30 psi minus 15 psi, approximately. Okay, or 15 psi, which is 15 psi, pounds per square inch, approximately here. So if the gauge pressure was here, 15 psi, 10 meters down, if I just tell you, oh, something is 15 psi, you don't know in the petroleum industry if I'm talking about psi G gauge or psi A absolute. Okay? And sometimes it's a big difference on your calculations, because there's a big difference between 30 and 15, between 1 and 2. It's a big difference, okay, in engineering. So anytime a petroleum person talks to you about pressure, they're obliged to tell you, is it bar absolute or bar gauge? Is it Pascal absolute or Pascal gauge? Okay? Is it PSI absolute or PSI gauge? So in the field units, we have PSI A and PSI G. It's used all the time. Okay? It tells you what kind of pressure it is. Unfortunately, with bar, now in Norway, you may see it being written bar A and bar G. It's like Americans living in Norway do it, and probably some Norwegians do it. But you'll sometimes see it written like this. But you can't do that with pascals, because PA, and you got PAA, nobody writes that. So if you're using megapascal, you have to write absolute, or you might shorten it with apps, or you might say megapascal gauge. You have to write it out. Okay? But you're obliged to use it, because the difference between 30 and 15, that's a factor of 2. Between 2 and 1 is a factor of 2. If the pressure is 5,000 psi, okay, or like in Ekofisk, the field pressure was 7,000 psi when they discovered it. It doesn't really matter if you say 7,000 or 7,015 psi. It kind of matters, but it's not really important. But in some cases, it can be very important. So in general, you basically want to always use this and this for pressures, measurement of pressure. And what most people have learned in high school and in other disciplines, they only use absolute pressure. Okay? But in our industry, you have to use both. And you have to specify what it is. Okay.
Is that Pascal, that picture?
Apparently so. I don't know. I mean, how he's so old, how did they have pictures of him? But it says here, Blaise Pascal. I never knew his first name. All right. That's when long hair was in vogue. All right. So now let's take a look at temperature. Well, let's see. Before we leave pressure, I'll just give you the translation from the different units conversion for pressure. So pressure units conversion. Now, in Appendix A of this SPE Phase Behavior Monograph, I'm going to stop writing this second part. I just say Chapter 6 or Chapter 2, or it's the book, the blue book. Okay? You'll find a complete set of units conversions. If you have an iPhone, you can go out and fetch an app. It gives you the unit conversions. Okay? But I'll give you the ones that you might want to keep in your mind. So you've got 14.5037 psi is equal to 1 bar, is equal to the 10 to the 5th Pascal. Okay, that's one unit conversion you should probably know. And then some people around still use the atmosphere as a unit. Okay. Well, let's see here. Basically, there's 14.69, I think it's 7 psi is 1 atmosphere. You'll have to check these things. The first one I know for sure. The second one I'm not quite sure about. And then I just realized today that the Brazilians are still using kilograms force per square centimeter.
Russia we too.
Huh?
In Russia we too.
In Russia too. My God, they should all be sent away to Russia or something. Or to, no, anyway, I used to use them. They used to have it on the pressure gauges in the laboratory. So you also, but I'm not sure exactly what's the difference between kilograms per square centimeter and atmosphere. What's the difference? Do you know?
I don't know exactly.
Okay.
Spelled O.98.
Okay. We'll look it up. So this in this book that we that I put up on the It's Learning, Appendix A, and we'll search for ATM. There we go. .01325. Actually, I knew that. Yeah, 1.01325. Oh, that was atmosphere. Yeah, that we already knew. Yeah. Now that's the ratio of these two numbers here. This would be atmosphere 1 bar, I think. We were looking for kilograms per square.
I always thought it was the other way around.
Could be. Let's see. There's 1 point. Let's see. Let's see. What I know is that. Let's check. Since we're not sure, we've got one. Atmosphere is the 14. Well, if we take the ratio of this, right? Then you get 14.69. I think it's 6 maybe, but I'm not sure, something like that. Over 14.5037. That is this, I think, 1.01325, if you check that. So that's 1 atmosphere is that many bar. Did I write that or did I write it opposite?
Yeah, I always remember like 1 atmosphere is like 101.3 kilopascal.
Yeah, so that would be right. Yeah, so I think maybe I wrote it wrong before.
And 1 bar is 10 to the 5 kilo, or 10 to the 5 pascal.
Right, that's here.
So
Yeah.
1 atmosphere is going to be equal to 1.013 times 1 bar.
Right.
So that's right.
10 to the 5th Pascal. But what we were looking for now was this kilogram force per. Yeah, I'm not going to go there because we don't use it often enough. But we could figure it out with pound to kilo. Here it is, kilogram force per square centimeter. There it is. It's 1.01. It's almost about 1.02 difference between the Pascal. Let's see, between bar and there's 2% difference between bar and kilogram force per square centimeter. So anyway, this is a pretty complete. This table A in Appendix A is pretty complete. Okay. This one number here, 14.5037. That's really the only number that and 14.696 or 7. These are the only two numbers I remember, but I can do almost any conversion with that, except to kilograms per square centimeter. Okay, so So now let's take the next one with quantity, symbol, and units. Will be temperature. And of course T, everybody's got that. And then units. You've got, in the SI system, you've got Kelvin with no circle thing in front of it. There's no, it's not written like that. It's not allowed to write that. And then you've got another not absolute temperature in the SI system is degrees Celsius, right? And those would be SI and metric. And then the equivalent for field units are degrees Rankine and degrees Fahrenheit. Okay? So these two here are absolute temperature. And these here are not absolute temperature. I don't know what you want to call those. So you have to be real careful using using degrees C and degrees F in PVT calculations, particularly equations of state, because you're not supposed to use them. You're supposed to always use absolute temperature. But when we talk to each other, we use the degrees C and the degrees Fahrenheit. Yeah.
Do you know what the reference for Fahrenheit is? Like someone told me that about 100 Fahrenheit is about body temperature or.
Yeah, I'll give you this conversion here exact. Okay. So what I'm just going to tell you is that you want to use this in your PVT calculations, and particularly the so-called equations of state, like the ideal gas law, the real gas law, any other equation of state. You generally want to use the absolute temperature. And the conversion, Kelvin is equal to degrees C plus 273.15. Degrees Rankine is degrees Fahrenheit plus 459.6, I think, 7 maybe. I don't remember all these digits. And the other thing you can note is that degrees Rankine is exactly 1.8 times degrees Kelvin. And if you kind of put all this together, you can actually go from degrees Fahrenheit by multiplying by 1.8 times temperature in degrees C plus 32, which is freezing point of water, 32 degrees Fahrenheit. Okay. So just water boils at 100 degrees C, and of course at 1 atmosphere. Okay, and 1 atmosphere. And that's equivalent, what you'll find, 212 degrees Fahrenheit. 1.8, 180 plus 32. And it freezes, water freezes at 0 degrees C, again at 1 atmosphere. And, not big effect, and that's 32 degrees Fahrenheit. Okay? So those are the temperature conversions that we need to know, the symbol, T, and there are many petroleum engineering correlations. Correlations to estimate properties, densities, and other stuff. Not equations of state, not rigorous thermodynamic equations, but empirical equations, okay, where they do data fitting. There are many of these correlations or equations that use degrees Fahrenheit. So it's a very common, you're going to have to get used to it. Okay. Any questions about temperature? We've got volume. And we've got capital V. That's a big V. Let's make it bigger. Capital V is volume. The SI unit, cubic meters. The metric unit, do you remember what that is? That's cubic centimeters, or sometimes they just write it cc. And before I leave this, at this point I want to make a comment about SI units. This is called a prefix. And the prefixes are, you know them better than I do, but they're, I don't know, we got M is milli. What's the next one? C is centi. That's 10 to the minus 3, 10 to the minus 2, and D is deci. All right, 10 to the minus 1. And then you got 10 is what? Is there one for 10? Huh? There's not 10, and there's not 100, but there's 1,000. 1,000, that's kilo. 10 to the third. Capital M, mega. That's also a food chain. You've been around town, not the reasons. 10 to the sixth is capital, I don't know after this. G? Capital G, giga. It's 10 to the ninth. Okay? Yeah.
10 to 1 is deca.
Oh, did I? D is deca. Is there not 10 to the minus 1?
10 to 1. Deca.
10 to the 1, okay.
With capital D.
Capital D.
Yeah.
It exists?
Yeah.
You're sure? Should we trust him? All right. All right. You know, when I went to school in Oklahoma, and it was this was communist. The SI system and metric was communist. So we didn't even talk about it. So that's why I don't know these things. You know, but now, of course, we know everything's okay. Communists are good. Everybody's good. Let's see here. So it's little d. Capital D is 1. Okay. Okay. Hold on to your shorts. Huh? Isn't that cool? Oops. Lost a little bit of the K there. Little K. So it's capital D. What's it? Deca? Okay. Okay.
And also, I think there's hecto for 10 to the second.
And never in, okay. These are also in Appendix A, I think. But what I wanted to bring out, what's important here, is not remembering, but what is very, very important with these prefixes is how they're used. And I'm sure you learned this in high school, but you probably forgot. Okay? It's the same as writing the 10 to the minus 3. So this centimeters cubed is the same as writing centimeters, centi, which is 10 to the minus 2 times meter, right? All of that cubed. Okay? So if we write centimeters cubed, then it's 10 to the minus 2. So that is 10 to the what? Minus 6th cubic meters. Okay. This is not what often people, not often, but I mean, is not this. It's rare, very, very wrong. Engineering, a factor of 10 to the fourth. You want to get a different job. Okay? Okay. Because we want to be within 10% on most of our calculations. Okay? Okay? So that's the prefix on. And then for field units, feet typically is feet cube. Very seldom do you have inches cube. Very seldom, but sometimes. And then we've got barrels. BBL is the symbol for barrels, which is spelled like that. And how they got BBL, I don't know. I always suspect it was some Texan who didn't know how to spell. He thought barrel had 2 B's or something. That was only funny when George Bush was president. But, no. So that's barrels, and we use barrels a lot because that's our main unit of, except in China and Russia where they use tons. Everybody else sells in $114 per barrel today. North Sea oil, $114 per barrel. So the barrel is a very important unit. And then we've got some other strange volumetric units that are very important. This is used for liquids, oil and water. But for gas volumes are almost always reported at standard conditions. Gas volumes are almost always reported at 1 atmosphere and 60 degrees Fahrenheit. It's kind of a standard. Now Petrobras or Brazil, they use 20 degrees C as a standard temperature, but most of the world is, well, at least in the SPE, the official definition of standard conditions is 1 atmosphere and 60 degrees Fahrenheit. 1.0135 bar. Absolute. Okay. It's 14.696 psi-A. And this is called a standard cubic foot. A standard cubic foot. SCF. Standard cubic foot. Or maybe feet. I don't know. Okay?
What about STV stock tank barrels?
Yeah, that will come back to. There's also special the barrel at standard conditions is usually written stock tank barrel like that. And this, I'll just bring that down here. STB, stock tank, which read standard condition barrel. Same 1 atmosphere and 60 degrees Fahrenheit. One atmosphere, 60 degrees Fahrenheit. But this standard cubic feet thing here is we've got some really strange ways to express that. We've got MSCF is 10 to the third standard cubic feet. And MMSCF is 10 to the sixth SCF. The M comes from the old, what is it, Latin or, you know.
Milli. That's 4,000.
No, this is, you know, when you watch movies, at the very end of the movie, they give you the date that the movie was made in.
In Latin.
Latin, thank you. That's Latin for 1,000.
Yeah, milli.
Million. What do you call it?
Milli, milli.
Okay. In Latin, okay. But MM in Latin, in way of counting, is 2,000, right? I think.
Yeah.
But the way we use it in America, it's M times M. It's a million. Okay? So this is Latin for 1,000. And this, the way this should be interpreted is 1,000 times 1,000. But if you write in Latin MM, I think it's 2,000. So, anyway, we use these a lot. So that you have to, like, you're Norwegian, they ship you off to Oklahoma City to work on the Eagle Ford gas shale. They probably will do it, or okay, and they talk about million standard cubic feet per day. So you have to learn that. And then there's BCF, which is 10 to the ninth SCF. And TCF is a very important one because this starts defining what we call giant gas fields. Okay? So these are approaching, that's the volume of a, probably wouldn't be a giant, but most places in the world be a giant, or very large, certainly a large gas field. So when you read the paper and they say they found Ormen Lange, for example, is, I don't know how many, it's around 10 TCF. The first Norwegian big field was Frigg. It was 6 TCF or 7 TCF. Troll, the largest field in Europe, gas field in Europe. Anybody? Yeah, Troll field. 45 TCF is a giant, really a giant field. The world's largest gas field, okay, is in Qatar, and Iran. Okay, Qatar got the biggest part of it. It's called the North Field. It's got 900 TCF, and the Iranian side, which is called South Pars, has got that. Well, they don't know, but around 300 TCF. Those are truly super giant gas fields. Troll is a giant gas field, but the 1 TCF, you have to be bigger than that to develop offshore gas fields. So it's kind of an important number. So these are volumes in petroleum engineering. They're special terms or units, and you really have to learn them. And for metric, you have, the way it's supposed to be written is standard cubic meter. That's the SPE. You write STD, cubic meter. But many people just do this, which clearly makes the SI committee shake, because there is no capital S prefix, I don't think. Maybe there is. But this, they just write capital S for standard condition. So you see that written like that. That's the way it's supposed to be written. And in old Norwegian stuff, they used to have what was called normal cubic meter. That was 20 degrees C, or 25 degrees C, and 1 atmosphere. But just forget I said that. Okay, sure. You might find some old report with normal cubic meters. Just a little bit different temperature, 20 or 25 degrees C. Okay? And then we got a few minutes left, and I want to introduce mass, symbol little m, and in the SI, the official unit is kilogram. That's the official unit. The metric unit was gram, which I don't even know if it's acceptable in the SI system. I don't think so. I don't think you're supposed to use the gram. But I think you can, but because the actual base unit of mass in the SI system is kilogram, which does equal 1,000 grams. And then in the field unit system is called pound, with this little m for mass, to differentiate it from pound force. Okay. And I forgot to give you conversions for the volume. Very important. So I'll do that. There's basically two numbers I remember. 35.31 cubic feet in a 1 cubic meter. And there are 6.28 barrels in 1 cubic meter. And what you'll see from that is that there's 5.615 cubic feet in 1 barrel. I remember, actually the numbers I remember, 35.31 and 5.615, but I think 6.28 is also correct. Those three numbers pretty much get you everywhere you need to go on volume. Any questions about volume other than that? We've got the mass, pretty straightforward. The mass conversion is is 2.2. I think it's 2.2. Something. $2.2046 pounds mass per kilogram. And of course, everybody knows that there's 1,000 grams per kilogram. But the main one is this 2.2 number. That's there is something called an ounce, which I believe there's 16 ounces in a pound. Is that correct? I think so. But petroleum doesn't use ounces very much for anything. I think it's 16 now. Okay.